got x squared y cubed to the square root of xy.
Good, good, very good. Okay, and the same idea applies. Like, let's say it's, do an example. Let's say it's the cube root of x to the 10th, y to the 20th. Now, okay, so here's how this same thing applies. You really want it to be x to the 9th, or a multiple of 3, and then you can multiply by x to the 1, because the 9 and the 1 go back to 10. Same thing with the 20 here. Like, you're looking for the one that's smaller than it, that's still a multiple of 3, and so then you just split it apart here. It becomes the cube root of x to the 9th, y to the 18th times the cube root of xy squared. So that, notice, like, the exponents don't have to be the same here, but on the left you multiply the exponents by a third, or divide by 3. So this is x cubed y to the 6th cube root of xy squared, like that. So it's the same idea. You gotta get it down to a multiple, the exponent down to whatever you have out here, multiple of 3.
All right.
Is that okay?
Yeah.
So let's have you try one here. Let's have you try the cube root x to the 14th, y to the 19th, we'll say, and go ahead and work that out. Let me know what you come up with.
All right.
How are you doing on this one?
I got 4 or not, sorry, x to the 4th and y to the 6th times
So cube root.
yeah,
Yeah, got it. Good.
cube root of x squared y.
Very good. Very good. Okay. All right. Now the only thing that makes these problems more difficult, and we'll just look at one together before we move to factoring, is like if I throw a number in there, like let's say it's let me think of a good one here. Let's say it's like 81. Sorry, the cube root of 81 x to the 7th, y to the 15th. Okay. All right. So in this problem here, you look at 81 and you break it apart. It's 3 times 27, 3 times 9, 3 times 3. Do you see how there's a triplet here?
Yeah.
Triplet. So you're looking for triplets. The reason you're with square roots, you're looking for doubles is because, well, you want to bring, you need 2 to bring 1 out. Here you need 3 to bring 1 out. But that means there's a 3 left over inside. So you can look at this as like kind of like we were doing there. It's 27 times 3, x to the 6th times x, and then y to the 15th. That is okay. That's good as is. This becomes the cube root of 27 x to the 6th, y to the 15th, times the cube root of the other stuff that like doesn't work out as nicely.
Yeah.
So this one on the left, the cube root of 27 is 3, x to the 6th is x squared, y to the 15th is y to the 5th, like that, cube root of 3x. Something like that.
All right.
And this goes on, this goes up, like it could be a 4th root, it could be a 5th root. I mean, it could go on forever. Like you don't, it's not just these two. These are the most common ones that you'll see, but you know, it could literally go up, you know, to any root. And you'll see some other problems in finance, no, not necessarily finance, like interest rate problems where they do go up. So that's probably like the short of it. Let's transition to factoring. Okay, is that okay, or would you rather do another quadratic formula problem?
Let's go on to factoring.
Okay, so let's start with GCF. We'll just do these in order here. So let me give you a GCF problem and you just see how you do. Okay, go ahead and look at this and see if you can tell me the GCF.
All right.
You don't have to factor this. I just want to see if you can tell me the GCF first. Probably should have said that. Sorry, I was just
the GCF is 9 x squared y squared.
yes. Okay, that's good, because if you don't get this right, like it doesn't matter what you factor it to. So yeah, I guess I take that back here. I do want you to look for or divide this out here. So go ahead and whenever you're ready, you can tell me what goes in parentheses.
All right.
Any questions on this?
No.
Okay.
Okay. I got 9xy squared.
Okay.
My,
So the nines do cancel.
okay, it's one of those. Okay.
Yep.
Minus 2y
Good.
plus 4x cubed y.
So when they have the same exponent, they go away.
Oh yeah.
Okay, so let's look at a couple of smaller ones here just to get you a little faster on these. Let me know when you get that down.
I got it.
Great. Okay, so let's say it's something like 4x squared y over 2x squared y. So you just as review here, you look at each of these, 4 over 2, x squared over x squared, and y over y. If they're the same on the top and bottom, they do cancel. So the y's would cancel, the x's will cancel, and then the 4 over 2 becomes just 2. You see that?
Yeah.
All right. Good. So the other, I guess the other thing that could happen here, which see, it wouldn't happen in any of these. So I guess that's it. Okay. So now the next type of factoring is called difference of squares. Difference of squares. And it has a formula here. It's given an a squared minus b squared, and it always becomes a minus b, a plus b. Okay, so a couple of examples here might be something like x squared minus 9. Okay, notice there's no square above the 9. So you have to rewrite this, and you'll do that a lot in math. You'll rewrite it into something that looks more like the form. What's the value of a and the value of b in this problem after you rewrite it?
A is x, and 9 is
B is
yeah. Oh yeah, b is 3.
3.
A
Yeah.
negative.
Yes, positive 3. B
Oh.
B is away from the negative.
Oh yeah.
Okay, so you write it as x minus 3, x plus 3, like that. Okay, so if you don't have it in a form where it's something squared minus something squared, you have to rewrite it until it's in that form.
Okay.
Okay, so this formula is key for doing this. Let me have you maybe try one here. Let's say it's y squared minus 36. So could you tell me what goes in the parentheses over here off to the right?
I got y minus 6, y plus 6.
Very good. Okay. Now it's possible that the order could be changed here a little bit. Like it could be 25 minus I don't know, w squared, like this. And it still is in this form off to the right. It's just that your a could be a number. Your a isn't always a variable. All right, so here it's really 5 squared minus w squared. So what would go up here in parentheses in that case?
$25.
It's got to be the number that's being squared. It's never this number.
Or W.
So a is 5. A
Yeah.
is 5 in this case. It comes first. It's always a minus b, a plus b. Like it doesn't matter. Like you don't want to think that the variable always comes first. It does not have to.
Oh.
Like, so again, a couple things here. Like it's never this, whatever this is, it's never this number, because it's got to have a little square above it. Like that's what you're trying to figure out. And then once you get that, you just do it in the order. In this case, your b is w. All right, so let me have you try one here. How about 81 minus k squared? Can you tell me what goes in parentheses?
Mine, or 9 minus k, 9 plus k.
Very good. Now it's also the possibility that they could both be variables. Like it could be x squared minus y squared. Okay. And this would become x minus y, x plus y. Okay. But that's really not the one that you most often see. You typically see something more like this, where you add a variable, but you have a number going along with the variable. So you still have to figure out what's squared to get back to the previous line. Like you still have to figure out your a and your b when you're doing something like this. So on the left here, it's x. On the right, it's 2y.
Okay.
Okay, so that you know that's your A. Your A is X. Your B is 2Y. So your A minus B can actually be more than just a letter, more than just a number. It can be a letter and a number. So do you see how this would become X minus 2Y, X plus 2Y?
Yeah.
You got to figure out what it is that's being squared, what it is that's being squared to get you back to the previous line. All right, so let's try another one here. Let's say it's 9y squared minus 25x squared. I want you to tell me what goes in parentheses here on the left and the right so that you get back to the previous line there.
All right. Uh, 3y minus 5x.
So 3y and 5x. Yep. So this becomes
Yeah.
in parentheses here. What would go in parentheses?
3x or 3y minus 5x. 3y plus 5x.
Good. All right. Let me give you just a couple here to try on your own. All right. So let's try 100a squared minus 49b squared. Let's start with that one. So go ahead and work that out. Let me know what you come up with.
You got 10a minus 7b and 10a plus 7b.
Very good. Let's do one more here. Let's say it's 1 minus 144x squared.
One minus 12x and 1 plus 12x.
Very good. All right, we just keep checking the boxes here. You know two of the types of factorings really well. The hard part is really just distinguishing between them. Now, sometimes you get a mixture of the two. Okay, so the like for example, let's say it's 100 minus 25x squared. Okay, while this looks like difference of squares, you actually want to first factor out the GCF. Can you tell me what the GCF is in this case?
25.
25. So it's 25 here. 4 minus x squared, like that. Now you keep going. You're like, okay, well, maybe the inside is factorable. And in this case, it is. Can you write this 4 minus x squared as the difference of squares for us? Basically, I'm asking you what goes in these two parentheses.
Okay. Uh, 2 minus x, 2 plus x.
Very good. Okay. So let's have you try one here, then we truly will move on. Let's say it's 36a squared minus 9b squared. So want you to factor this. It does have a GCF, so you want to do that first. And then give me the difference of squares factoring.
I've been tripped up by the variables. They're different.
Yeah, so let's start with just the GCF here. So that becomes 4a squared minus b squared. And then your goal still is to figure out, well, what is it squared minus what is it squared? And in this case, it's 2a and just b. So that becomes 2a minus b, 2a plus b times 9.
Okay.
So let me give you one more here. You know, when you get all that down, I'll won't use the same letters. That is deceptive. It's very difficult. Get that down.
Yeah.
Okay, so here's another one here. Let's go 144 w squared minus 36 v squared. Let me know if you're having any trouble finding the GCF on this one.
All right. Okay, I got 4, and then, or 4 times 6w minus 3b,
Okay.
and 6w plus 3b.
Yes. This is, well, what you have is correct. It does not get the GCF. So the GCF is actually 36, and that's where I, wasn't sure if that was too big. Some of these don't work without, giving you the GCF, but then it becomes 36 2w minus v 2w plus v, and you might wonder, well, how can I get there? Well, if you factor 3 out of the first one and a 3 out of the second one, you have 2 3s, which makes 9. 4 times 9 gets you to the 36. Okay, so let's just reset here. We're going to move to a different type of factoring problems. But good job. I mean, those are tough there at the end. Lots of number manipulation. So we're going to move to what I call the a equals 1 type. We're looking at ax squared plus bx plus c, but a is 1. A is 1 here. So you're generally looking for 2 numbers that multiply to c but add up to b. So I could ask you something like this, like x squared plus 13x plus 36. And I would ask, the instructions would say to factor. You're trying to find 2 numbers that multiply to 36 but add to 13. 2 numbers that multiply to 36 but add to 13. Can you determine those 2 numbers for us, please?
Sure. Uh, 4 and 9.
4 and 9. So this would be x plus 4, x plus 9. So this only really gets challenging if there's 2 possibilities. One is like the number gets so large, or you can't think of the factors that work here. Like here's another one here. Let's say it's x squared plus 19x plus 48. Okay, 2 numbers that multiply to 48 but add to 19.
Uh, 3 and 16.
Yes. So what would go in parentheses?
X plus 3, x plus 16.
Yes, very good. So I call within this type, these are the ones where they're both positive. The next type that we've been looking at is where they're both negative. So I could give you a problem like this, like x squared minus 10x plus 24. 2 numbers that multiply 24 but add to negative 10. Which means you have to try to think about, like, well, how do you get back to a positive number? Well, obviously a positive times a positive gets you to a positive. but if they're both negative, that also gets you to a positive. So the idea is here, if you two numbers that multiply to 24, but add to -10, the two numbers are either both positive or both negative. Because you want -10, they'll be both negative in this case.
That'd be x plus 2, x minus 10.
They have to both be
Or
positive or both be
x
negative.
minus 12, sorry.
So here's what I heard: x minus 12, x minus 2, like that.
Or x plus 2.
But they have to both be positive or both be negative. So that means you don't have them. Like if you're trying to like go back and forth on the signs, you don't have them. They have to both be positive or both be negative. So it must be another factor for this.
-4 and -6.
Yes. So x minus 4, x minus 6. Okay, so let's try another one here. Let's say it's let's see here. X squared minus 11x plus 30. I guess I don't need those parentheses there on the end.
X minus 5 and x minus 6.
Very good. Very good. All right. Great. So the last case, the very last case here, and this is the absolute hardest of them all, is a problem like this. It'll be like x squared minus 2x minus 15. So to get to a negative number, you're multiplying one positive and one negative, or one negative and one positive. Okay. And then this is the hardest one, because you have to get the signs right. Like you can't be off by the signage here. You know, like you can't, like in this case, the answer is 5 and 3, but which one is it? Is it -5 and +3, or +5 and -3? Well, the answer is the one that adds up to -2, like that. So this one is x minus 5, x plus 3, like that. So let's have you try one here. Let's say it's x squared minus x minus 20 minus 1x minus 20. See what you come up with on that one, please.
X plus 4 and x minus 5.
Yes. Very good. All right, let's have you try one more here. Let's go x squared minus 4x minus 32.
X plus 4, X minus 8.
You got it. Very good. And the order doesn't matter. You can, meaning like it can be, I wrote it as X minus 8, X plus 4. You said X plus 4, X minus 8. That doesn't matter. The signs do matter, but the order does not. All right. Well, I think we can stop right there. Did a lot of problems today.